Yeah, sorry. I forgot to record. Okay, but I started it now. Okay, we just did quotient rule. All right, so y prime is, okay, in the blue, I can combine 1 plus 2x minus x will just be 1 plus x. And in the denominator, I'll have 1 plus 2x to the 3 halves. Right? Because I can move this 1 plus 2x to the negative 1/2 power to the denominator and combine it. That's why I left it, if you were wondering why I kept putting a 1 there. It's because we're going to combine that exponent. Can you show it the other way too? Sure. After I finish, let's come back to it. Okay, so let's take a look. We have a big table of values here, and we want to do the derivative at different values. So the first one says the derivative of f of x times g of x at x equals 1. So this is just product rule. Okay, so well, hold on. Let's go through. Think u and v. Okay, so it's going to be u prime times v plus u times v prime at x equals 1. Okay, so I'm going to write it out with my function notation with f and g. So u prime is going to be f prime. It's going to be f prime of 1 times g of 1 plus f of 1 times g prime of 1, right? I'm just taking turns with derivative times the value. So now we go back and we look at our table. So f prime of 1 was 5/3. What was g of 1? 1. Plus f of 1, 1/3, times g prime of 1, 2/3. Okay, so I have 5/3 plus 2/9. Oh no. Well, 5/3 would be 15/9, so 17/9. 17/9? Yeah. Okay, next one is a quotient rule. So this derivative is going to be, and again, now we're evaluating it at x equals 2, so it's going to be low. So it's going to be f of 2 d high, so that's going to be g prime of 2. Take high, g of 2, d low, f prime of 2. Cross the line and square the low, so it's going to be f of 2 squared. So again, it's just a matter of laying out the rule, picking the proper terms. It's like a game. Yeah, this is fun, honestly. It's like a puzzle. But it's no, the worksheet's going to be, oh, sorry. Okay, f of 2 is 1. G prime of 2 is -4. Minus g of 2 is -1/2. F prime of 2 is 1/4. And f of 2 is 1 squared. Okay, so that gives us -4. Did I make a mistake somewhere? No, it is 1/4. Okay, that's all right. That's all right. I just want to make sure I didn't make a mistake. So it's -4 plus 1/8. I got 31/8. Positive or negative? Negative 31/8. Okay. Next one, we have a square root of f of x. So think of this as an f of x to the 1/2 power. This time we want it evaluated at x equals 3. So we're going to move the 1/2 to the front. Keep f of 3. Right? To the -1/2, times derivative of the inside. Don't forget that f prime of 3 multiplied at the end. That good? Okay, so I have 1/2. Now, f of 3 is what? 1? Oh. So 1 to the negative 1/2 would still just be 1. And f prime of 3 is 0. So it's 0. Okay, next one. This is a chain rule. It's f of g of x. So we want f prime of g of 4 times what? Derivative of the inside. G prime of 4. Okay, so f prime of g of 4. So if we look at g of 4 is 1. 5/3. G prime of 4 is negative 1/3. Negative 5/9. Good. Yes. Okay, so it's f prime of g of 4. So we went to g of 4, which is 1. So then f prime of 1 was 5/3 times g prime of 4, which is negative 1/3. Okay. All right, last two like this. So again, this g cubed means really it is g of x to the 3rd power. So just remember that cube when it's right next to the function notation, it really means it's on the outside. So if I do, so it's going to be 3 g of 2 squared times g prime of 2. So derivative of the outside. And then we have 3. What's g of 2? Negative 1/2. So it's going to be negative 1/2 squared times, what's g prime of 2? Negative 4. Okay, well that makes it kind of easy just here. So this would be negative 3. So just negative 3 because the 1/4. That would be 3/4 times negative 4. Good. Okay. Last one here, g prime of f of 2 times f prime of 2. So what's g prime f of 2 is 1. What's f prime of 2 is a 4th. And what was g prime of 1? So 2/3 times a 4th. Excellent. Mm-hmm.
So I understand, like, after, like, I understand what to do after you write it all out, like, the g prime and f. So, like, how do you figure that out, though, so quickly?
So personally, I keep thinking of my outside-inside rule. So I think the derivative of, so what's the outside? It's the g. What's the inside? It's f. So I do derivative of the outside, so g prime.
G prime of the regular
one times the derivative
of the inside.
Okay? All right, last two problems. Find the slope of the line tangent to the curve. Y equals sine to the 5th x at the point where x equals pi over 3. So
would this be 5 sine x to the 4th?
5 sine of x to the 4th times
Times cosine x to the
just cosine x. Because if you look at the inside is just sine of x. Okay, so we've taken care of the power in that first step, and then we kind of ignore it.
So that's it.
Yeah, and then I just want to find what's y prime of pi over 3. So And yes, I want you to do this without a calculator. Okay, so let's think. What's sine of pi over 4? 1 over. Did I put the wrong thing? I'm so sorry. I was getting all. There we go. Root 3 over 2. So it's 5 root 3 over 2 to the 4th times. 1/2. Okay, root 3 to the 4th. Well, root 3 squared would be 3, so then that would be 9. 9 times 5 will give us 45. In the denominator, 2 to the 4th will be 16. 16 times 2, 32. Okay.
That's the end.
And that's all we had to find there was the slope. If I asked you to find the equation of the line, you would just plug this back into the original to figure out what the y-coordinate was.
So that's M.
That's M. That's all we had to find for this one. Okay, last one, and then I'll give you the worksheet. We want to show the slope of every line tangent to this graph is positive. So we want to show that dy dx has to be greater than 0. Okay, that's what we're trying to prove. Don't worry, it's not like a prove, like a geometry prove. We're just going to show this with the calculus and then algebraically. So we're just going to start with, I'm going to rewrite this with a negative exponent so that I can use the power rule. Okay, go ahead and let's find the derivative of that. That'll be negative 3, 1 minus 2x, good, times, which equals, okay, so, well, what is the numerator? So is the numerator greater than 0? Okay, so since 6 is greater than 0, and well, what happens when you have an even power? Okay, so no matter what, yeah, it's going to be positive. Then